Now I'm going to talk about why the Coriolis force causes everything in the northern hemisphere to deflect to the right. So here we have a plane in the North Pole, and that plane's heading straight down a particular longitude line, going straight through China. Let's say it's ending up there in the Himalayas. So it's going from the North Pole straight south to the Himalayan mountains. Because the Earth is rotating underneath that plane, so that plane's flying to that destination, it's rotating, that the plane will actually end up way further west of its intended target. And so it'll actually end up over here in the Middle East instead of ending up in the Himalayas because of that Earth's rotation happening underneath that plane flight. So one way to showcase the whole Coriolis force. Now that Coriolis force is going to be more exaggerated the closer you get to the poles. Along the equator, it's not really too much of an exaggeration, in fact, none at all. Whereas we get closer to the poles, and it's even more exaggerated, that whole Coriolis force. And so once again, this is a way to showcase the whole idea of everything in the northern hemisphere deflecting to the right, and everything in the southern hemisphere would be then subsequently to the left. And so finally, taking in sum, the pressure gradient force and the Coriolis force, which force explains the direction of the yellow arrow? Pressure gradient force, high to low. Which helps explain the direction of the purple area? Coriolis force. So then the net result of the pressure gradient force and the Coriolis force is very much a general bend to the right of these arrows. Get that stuck in the head for why we're going to see a ton of arrows in the northern hemisphere bending to the right, and then ones in the southern hemisphere bending to the left. It's the combination of the pressure gradient force and the Coriolis force working together so that the average of the two creates this curve to the right.